Today we are going to discuss continuation of aggregation functions. Fold function. What is fold function? Fold function also similar to reduce function, except that it will take one additional parameter called initial value. Fold function takes initial value. So initial value is applied on partition level. Initial value applied on partition value. Remaining, it will take one more parameter called function. So similar to reduce function, it is taking function and additionally it is taking initial value. So this initial value may be zero value, or we can pass argument. If you pass argument, that argument is applied on all partitions. So results, I said reduce function and fold function applies the same operation on partition level, results of partition level. You remember, both reduce function and fold function applies on partition level and results of partition level same operation. Okay, let's take one simple example. So here sc dot range, I'm passing, I'm creating one collection 1 to 10, increment by 1, number of partitions are 2. So first partition assume 1 to 4 and second partition is contained 5 to 9. So initial value, what I'm saying, r1 underscore fold, r1 dot fold of 2, initial value is 2, and I'm using function x comma y equal to x plus y. So we are using function. So first initial value, what is 2? So earlier in reduce function, first it performed 1 plus 2 and stored result in x, right? But here initial value is 2. So 2 is passed to x, and from list 1 is passed to y, and 2 plus 1, 3 is storing in x, and 3 plus 2, first argument. So like this it will implement what? Execute aggregation operation. Finally we get a result, right? So result we have 12 plus 37. Okay, result also it is applying initial value 2 plus 12 14, 14 plus 37 51. So in this way we get output. Okay, so let's see practically. Let's start SBT console. So it will start SBT Scala console. Okay, it is started Scala SBT cell. Then import org dot apache dot spark dot underscore. Okay, imported package. Now create val s equal to new spark context, and I'm passing spark context. I'm passing new spark conf dot set, and I'm setting spark dot master, and master I'm setting local. Okay, next one dot set, I'm setting application name spark dot app dot name. Application name is Spark Core app. So we created Spark context. It is going to create a Spark context. Let's wait to create a Spark context. Now Spark context is created. So it is created web UI. Okay. Then sc.set log level, and I'm setting log level is warning. So log level is set. Now what I'm doing, I'm creating one RDD. So val R1 equal to sc.range 1 comma 10, increment by 1, and number of partitions are 2. Then R1 dot collect dot for each println. Okay, so we are seeing values, right? 1 to 9. Okay, now val R1 underscore fold, R1 underscore fold equal to R1 dot fold. Initial value I am saying 2. Okay, next I am applying function x comma y implies x plus y. So result is 51. Okay, so did you got it right? Both reduce and function applies partition level same operation, results of partition level same operation. Hello team. In previous class we applied reduce function. In this class we applied what? Fold function. What is the difference between reduce function and fold function? In reduce will take other function as a parameter, but fold function takes two parameter. One parameter is initial value, another parameter is function. So this initial value is applied on partition level and results of partition level. Then whatever the custom function we are writing, that function also applies on partition level, results of partition level. Okay, so what is the disadvantage of both reduce and fold function? Both reduce and fold functions applies on partition level same operation, results of partition level same operation. Yes or no? Reduce function, fold function both applies on partition level same operation, results of partition level same operation. But I want to apply different operation on partition level, different operation on results of partition level. I want to apply partition level different operation, results of partition level different operation. Then we go for aggregate function. Aggregate function resolves both reduce and fold function problems. It will applies different functionality on partition level and different functionality on results of partition level. Okay, let's see aggregate function. Syntax of aggregate function: rdd dot aggregate initial value same as fold function, and it will take two functions, function 1 and function 2. Function 1 applies on partition level, function 2 applies on results of partition level. Function 1 applies on partition level, function 2 applies on results of partition level. So you can take different custom logic for function 1, different custom logic for function 2, different function logic for function 1, different function logic for function 2, so that we can achieve partition level different operation, results of partition level we can implement different operation. Okay, let's take one simple example. See, val r1 aggregate, r1 dot aggregate initial value is 2, x comma y implies x plus y. Partition level I am applying plus addition operation. So we got 12 and 37, right? Results of partition level I am applying different operation. So this is 12 and 37, right? Results of partition level. Here we are applying multiplication operation. 2 into 12, 2 into 37. So we get triplet. Okay, let's see. R1 dot aggregate of 2, x comma y implies x plus y comma a comma b implies a into b. Let me change this syntax. So this complete is one value, right? And this complete is another value. Let me check one time here. Aggregate operation in Spark. Let's see syntax. No, not clear. What is the error we are getting? Type error. Yep, type error. So syntax is same. Little overload method plus with alternative. Let me check error type mismatch. Let me check one more error here. Let me use this syntax. So here by default it is taking different type of argument. That's why it's giving error here. So only one thing I did, uh, here I used long input argument initial value type. I used long. So we got what? Triple 8. So these values are by default uh, range created some list of values, right? Those values are considered as long. Then here uh, default value is taken as different type. That's why while calculating we are getting output is max value. So clearly I'm specifying 2 is long type, 2 is long type, so that we are getting without any error. Is it clear, right? Hello? Yep. Next important topic is pair RDD. Pair RDD. Pair RDD means we can create key value pair RDDs. Key value pair RDDs. What is the advantage of key value pair RDD is we can apply based on key we can perform some operations or aggregation operations. For list of values we can perform aggregation operations. Example, this is my list object, local object. This list object contains some values. So we can convert this list object into RDD by using make RDD or parallelize. You remember, right? sc dot parallelize method or sc dot make RDD. By using these two methods, we can convert local object into RDD. Sorry, RDD, right? So we got one RDD. From this one, what I'm doing, I'm creating key value pairs. Key value pair. So here R1 dot map. Map means it reads each value of local each value of RDD, right? So each value here is passed to X. Then X comma 10 means 1 comma 10, 2 comma 10, 3 comma 10, 4 comma 10, 5 comma 10, 6 comma 10. We are creating key value pairs. Key value pairs. Let me first execute this one. Val list equal to list of 1 comma 2 comma 3 comma 4 comma 5 comma 6. Okay. Val, what is the RDD name? R1. Val R1 equal to sc dot make RDD, and I'm passing list. It will convert RDD. Next, what I'm doing, val R2 equal to R1 dot map of X implies X comma 10. X comma 10. Okay. Then R2 dot collect dot for each println. 1 comma 10, 2 comma 10, 3 comma 10, 4 comma 10, 5 comma 10, 6 comma 10. We prepared key value pair, right? By using map function for each value for each value we converted into key value pair. So once we have a key value pair, then there are some methods like count by key, count by value, count by key, count by value. Pair RDD contain two methods, count by key, count by value. It will count the number of keys in a key pair, and count by value will count the number of values in a key in a pair in the RDD. Let's execute this one. So R2 dot count by key, count by key. Count by key. So 5 implies 1, 1 implies 1, 6 implies 1, 2 implies 1, 3 implies 1, 4 implies 1. So for each key is repeated one time. For each key repeated one time because there is no duplicates, right? Next one, count by value. Each value also repeated how many times? 1 comma 10 is repeated one time. 5 comma 10 repeated one time. 2 comma 10 repeated one time. 4 comma 10 repeated one time. So combination value. To print key value pairs, we used R2 dot collect dot for each. To print only keys, so R2 dot map, it reads each row, right? Each row means key value pair, right? So key value pair is presented in X. From map, how can we read key means X dot underscore 1 is key. X dot underscore 2 is value. So to print only keys, we use this approach. To print only values, we use this approach. I want to print only keys. R1 dot map of X implies X implies X dot underscore 1 dot collect. So we are getting only keys. X dot 2, X dot underscore 2, we are getting all values. So in this way we can read keys and values separately. If you call direct R2 dot collect, it will print key value pairs, right? From key value pair, if you want to print only keys, we use R2 dot map of X implies X dot underscore 1. So we get all keys. X dot underscore 2, we get all values. So to add 20 comma 32 each key value pair, we are using R2 dot map X implies X dot underscore 1 plus 20 comma X dot underscore 2 plus 30. So it convert into in this format. So we get 20 comma 40, 22 comma 40, 23 comma 40, 24 comma 40. Each value we are adding, for each key we are adding 20. Okay. One more example. Let's take, we have a value array. Uh, array contain tuple, list of tuples. Array contain list of tuples. Array contain list of tuple. So this is one tuple. This tuple contain employee name, employee gender, salary of employee. Tuple contain employee name, employee gender, employee salary. Okay. So here we are converting this array into RDD. Let's first convert this array into RDD. So we have an array with a list of values. Then convert this one into RDD. Val RDD 1 equal to sc dot make RDD and pass a. So we got RDD. Let's see RDD 1 dot collect dot for each println. So we have list of values, right? Then what I'm doing here, next print only female records. Print female records. Print female records. Then we use filter, right? Filter option. Then tell me how to print RDD1 dot filter. X implies, so it pass entire value, right? Entire record to X. Okay, X. Then X contain in, this is tuple 1, tuple, this is entire tuple, right? How do we access tuple data? X dot underscore, let's take 2, x dot underscore 2. Then we are using what? Equal to operation, comparison operation. Then we are using equal to single quote female. Then collect. Only female records we are collecting. How? So this is string, right? Then we got 2 records. We have 2 female records. So we got 2 female records. Next, check only male records, print only male records. We got all mail records, right? So by using filter, by using filter function, we can filter records from RDD. Each RDD contain RDD is a collection of tuples, right? Here collection of tuples. So we converted array into RDD. Array contain list of tuples. So RDD contain list of tuple. So to access tuple, we use x dot underscore index. So index starts from 1. So male index is 2. That's why we are calling x dot underscore 2. It returns gender. We are comparing gender with our required value. So print male records whose salary greater than 30,000. Whose salary greater than 30,000. So 30,000 means here we have two records, right? 40 and 60. 60,000. Print male records whose salary greater than 30,000. We want male records as well as we want what? We want. So then here use AND operation and x dot underscore 3 greater than 30,000. Let's try this syntax. So we get 40,000 and 60,000, right? So we got two employee records. Two employee records. So next one, sum of salaries of employees gender wise. Sum of salaries of employees gender wise. So this is we have already array. We converted array with RDD. Okay. Then so we are converting. We want to perform gender wise, right? So we are mapping. We are mapping x dot underscore 2 comma x dot underscore 3. What will happen here? RDD2. So what I am doing? Well, RDD2 equal to RDD1 dot map of x implies what I am doing? I am creating one key value pair. What is that? X dot underscore 2 gender, right? Comma x dot underscore 3. We are getting what? We are getting key value pairs. Then RDD2 dot collect RDD2 dot collect for each println. So we got gender wise values, right? Gender wise values. Then once we got a gender wise value, we have different functions. So group by key, it will perform group wise aggregation. Group by key operation performs group by key. How it will perform? Observe. So we have RDD2 dot group by key, group by key. Okay. Then val RDD3 equal to rd2 dot group by key. Okay, then rdd3 dot collect dot for each println. So we have what? Female group, right? Male group. Yes or no? We got female group, male group. Then apply sum operation. Then apply sum operation. Gender wise sum. Well, gender wise sum equal to RDD3, right? RDD3 dot map. So first it will read this record, right? This record. So first record is gender, comma, x2 dot sum, x2 dot underscore 2 dot sum. So it is list of values. So it is performing sum operation. Then if you use dot collect dot for each println. So we got gender wise sum operation. So first we are grouping based on key, then we are applying sum operation. We are applying based on key and we are grouping based on key, then we are applying what? Sum operation. So here we are writing multiple steps, but in application, instead of writing multiple steps, we can write a single step to perform entire operation, sum operation. First we are reading only gender and salary, means map. On that map, again we are performing group by key. On that we are performing what? Sum operation. Yes or no? So we can do in a single step. Instead of writing multiple statements, then we can write like val sum equal to rdd1 dot map. So we got x implies what we are doing, x dot underscore 2 comma 2 comma x dot underscore 3, right? So we get one RDD. On that again we are applying dot map. So what we are doing? Group by, right? Dot group by key. On that again apply map of x implies what we are doing, x dot underscore 1 comma x dot underscore 2 dot sum in a single line. Here also we ignored one more bracket. Then finally sum dot collect dot for each println. right? Instead of writing multiple statements, we can call a single statement. So previously we taken multiple statements. In this we taken single statement. It will reduce lot of complexity, right? Multiple steps, and we are converting in the single statement. So this is functional oriented programming language advantage. On result we can apply another function. On result we can apply another function. Like this we can apply functions functions on one function, on function one. Like this we can apply any number of functions on top of results. Next, very important one is reduce by key. We saw group by key, right? We saw group by key. What group by key did? Based on the key, it will prepared groups, right? Based on the key, it is prepared group. Yes or no? Same reduce by key also performs grouping operation. First, it performs a grouping operation, and next it performs aggregation operation. It performs both the operations. Data is combined so that each partition there is at most one value for each key, and then suppose happens and it is sent over the network to some partition particular executor for some action such as reduce. So reduce by key will aggregate Y key before shuffling. Before shuffling, it aggregates before shuffling. So what is the advantage over group by key with reduce by key? In most of the interviews, you get a question like what is the difference between group by key and reduce by key? Group by key and reduce by key. You will get this question. What is the difference between group by key and reduce by key in Spark? So this is commonly asked question. This is commonly asked question. Let's see here only. There is no diagrammatic explanation. Let's go one more. This is the difference. Observe. Databricks site is very good informative site for Apache Spark. So Databricks. Observe. Reduce by key. What is reduce by key is? Here reduce by key groups 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 data in partition level. We have three partitions, right? Reduce by key groups data at partition level and performs aggregation here only. It groups data and performs aggregation, and results of partition level we get from this we are getting two values, from this we are getting two values, from this we are getting three values. We have list of values. From this we are getting less list, right? So here it is performing aggregation operation at partition level. At partition level. So it is performing aggregation operation at partition level. So we get what? Less data over the network. Over the network, we get less data. If you see, observe here group by key, same data only, same data. So we have two values here. We have four values. We have four values. Then it is grouping. It is grouping here. So it is created for A. It is created one group. B, it is created another group. Same thing. Here we have A and B key value pairs. So if you observe partition results, we have less. So aggregation happens at partition level. Aggregations happen at partition level. So that network, maybe this is executing in one machine. So we have a multiple partition. Partition 1 is executing in one machine. Partition 2 is executing in another machine. Partition 3 is executing in another machine. Finally, results of this is going to form other partitions, right? Results of partition. So these results may be created in another machines. So data is travel through the network, right? If reduced by key reduces number of conversions, yes or no? So we have less data in child partitions. But if you observe group by key has more data in child partition. So number of network traffics are more in group by key. In group by key, it will not perform aggregations at partition level, where it performs aggregation at child level. It performs aggregation at child partition level. So what is the disadvantage here? Data shuffling data between multiple partitions, right? So for this partition, we are getting data from this partition, this partition, this partition. So keys are more, A keys are more. Here for this partition, we are getting data from first partition, second partition, third partition. So data we are getting more. So shuffling happens more times, right? Data travel in network, more data is travel in network from different partitions, right? So in group by key, data is not grouping at partition level. It is grouping in child partition. So group by key, first we group based on key. So it will create a child partition, and on that child partition we can apply some operation or any aggregation operation. But what is the advantage of reduce by key? Reduce by key applies aggregation operation on partition level. So results of child partitions contain less data. So it reduces number of network calls. Did you understand difference between group by key and reduce by key? So you will get in any interview, most of the times you will get this question. What is the difference between group by key and reduce by key? Okay. So we have a array. We have an array with these values. We have an array with these values. This is the array. Then convert to this one into RDD. Convert to this one into RDD. So we are converted RDD x1. Then observe x1 dot group by key collect. X1 dot group by key dot collect for each. Yep, it's a function name. Group by key dot collect dot for each. x1 is RDD, group by key dot collect dot for each. Yes, we are executing correct only. Only one thing, again we used here greater than symbol. T as having 40 and 44. A is having 20 comma 35. B is having only 10. C is having 30 comma 40. Same thing, use reduce by key. Reduce by key. Yep, we have to pass this one function. Reduce by key, we have to pass aggregation function, right? We cannot call directly. In reduce by key, and we have to pass function here. X comma y implies x plus y. Group by key doesn't have aggregation functionality in it. In reduce by key, we pass aggregation operation. This aggregation operation applies at partition level only. Then results of partition, we get less data. So aggregate grouping operation performs plus aggregation applies on partition level. So results of partition level, we get less data. Finding maximum value in group level. So we use if condition. So we are using here instead of function applying here, we are applying aggregation, right? In each group, I want to find the maximum value. So each group contain, this is the each group value, right? So D contain 40 comma 44. A contain 20 comma 35. B contain 10. C contain 30 comma 40. So D which is greater 44, right? A which is greater 35, right? B we have only one value, that's why 10 is greater. C we have 30 and 40, 40 is greater. Then we can write in this way. Finding maximum value. So we are writing if x greater than y, if x greater than y, then x, otherwise colon y. So we can apply conditional operator here. Sorry, conditional operator, or we can use if x greater than y, x, else y. So we got maximum value. If you want less values, then we use x less than y, then x, otherwise y. So this is minimum value in list. This is maximum value in list. Fold by key. We know fold operation, right? What is fold operation? Fold function execute partition level and results of partition level. And results of partition level. Fold takes initial value. Fold takes initial value and function. So whatever the function we are passing, whatever the initial value we are passing, this is applied partition level and results of partition level. Yes or no? Fold function, fold aggregate function. Same as we have fold by key, fold by key. Fold by key merges the value for each key using associative function. So here fold by key, initial value, and this is the function. This is the function we are applying. So we are creating RDD with two partitions. This is two partitions. So partition level it applies, as well as results of partition level it applies. Results of partition level it applies. So this initial value applied for each group. First, fold by key performs grouping operation based on key. Grouping operation based on key. Then it applies this condition on each group. So initial value compared with the first value. So A contain 20, 40, 50, right? Then first it will compare 40, 40, 40, 40. 40 is X value, next 40 is Y value. Then 40, 40, 40 less than 40, no. Then first 40 stores into X. Next second value is what? 20, right? First 40 and 20. 20 is 40 is X value, 20 is Y value. So 40 less than Y, 20, no. So we get Y value 20 into X. Next one, it will take 40 is into value Y. So 20 less than 40, yes, we get 20 into X again. Next iteration, it will take another value 50. 50, 20, 50. 20 less than 50, yes, X value stores again into X. Then finally we get A is 20. So additionally we are using initial value. Other than that, nothing. Everything is same as previous, reduced by key only. It executes in this way. We have two partitions. First partition, these are the values. Second partition, these are the values. For A, it is applying 40, 20. So in this, which is minus smaller, this one. So B, partition level 40, 30, 30. C, 40, 10, 10. Coming to partition 2, same. B equal to 40, 45. 40 is the lesser. 40, 56. 40 is the lesser. 25, 40, 25. 25 is the lesser. A, 40, 50. 40 is the lesser. Then again we got these values. A is 20, 40. From this, if you observe, this is 20. From this we have 40, right? Two values. B, 30. Coming to here, 40. C, 10 here. And coming to this one, 40. Next D, here we have only one. What is the 25? Same as aggregate by key. Aggregate function, right? Same as aggregate by key. Aggregate by key takes three parameters: initial value, function 1, function 2. Function 1 applies on partition level, function 2 applies on results of partition level. Same, only one thing, here we have a key value pair. Data is in key value pair. So if it is a data is in key value pair, we use aggregate by key, reduce by key, fold by key. If data is not in key value pair, then we use reduce function, fold function, next aggregate function. If data is in key value pair, we use fold, reduce by key, fold by key, aggregate by key. Functionality cannot change. Functionality is same. Partition level, results of partition level. Partition level, results of partition level. Reduce and fold applies. Result partition level, results of partition level same. Aggregate applies. Partition level function 1, results of partition level function 2. Fold by and aggregate contain additional one, initial value. Initial value. Did you understand these functions? Do you have any doubt with these functions or any query in these functions, team? Okay. One important note: reduce by key, aggregate by key, combine by key, preferred over group by key. Why it is preferred over group by key? Group by key, shuffling, in shuffling, it moves more data. In shuffling, it moves more data. That's why people are recommended reduce by key, aggregate by key, combined by key, alternative to group by key. So in interviews, you get this question: group by key versus reduce by key versus other keys. Group by key operation does not perform any computation. That's why in partition level, data moves, shuffling moves more data. Reduce by key, another keys applies partition level aggregation operations. So results of partition means child operation, less data is moved. So in huge volumes of data, if you use group by key, what will happen? Shuffling happens more. So result child partitions shuffling is more. To avoid that one, go for, instead of group by key, go for other keys. Okay. Next, very important one, repartition versus coalesce. What is repartition, Prasad? Already we read repartition. Already we discussed repartition. So this is one of the important question. Whatever the questions we are seeing, right? You will get these two questions in any of the interview. You will get these questions in most of the times. You will get these two questions. Repartition means we can increase, we can decrease existed partitions, right? We can increase, we can decrease existed partitions. Coalesce means we can decrease, only we can decrease, we cannot increase. Only we can decrease partitions. So we can merge the partitions into single partition. Coalesce is used to merge multiple partitions into single partition. But repartition, we can increase or we can decrease partitions. Repartition can be increase or decrease. Coalesce can allow only decrease. First difference. And next difference, repartition involves shuffling, but coalesce does not involve shuffling. Repartition involves shuffling. Why it involves shuffling? Can anyone guess why it involves shuffling? Assume we have a 3 partitions. We are increasing 6 partitions. We are increasing 6 partitions. So 3 partition data moves to 6 partitions, right? So shuffling involves. Yes or no? Shuffling involves. Coalesce. Coalesce, we are merging all partitions into single partitions. There is no shuffling. There is no shuffling. All partition data combines into single partition. Data is not moving, right? One partition to multiple partitions. When we say shuffling is happen, Mahesh, sorry, Ravi, when we say shuffling is happen, Ravi, when we say shuffling is happen, one partition data moves to multiple partitions. One partition data moves to multiple partitions, multiple child partitions. We call shuffling. Yes or no? So number of connections are greater than number of connections are greater than number of partitions. Then we call shuffling is happen. Shuffling is costly operation because data moves to multiple partitions. Partitions may reside in different machines. In that case, it consumes more network calls. Okay, but coalesce doesn't involve shuffling because we are combining multiple partition data into single partition. Number of partitions are less than connections, or number of partitions are equal to number of connections, right? Less than or equal to number of connections. Then if number of connections are less than or equal to number of partitions, then we can say shuffling is not happen. Okay, use repartition when data has to be used further. If we are if you want to use data further, then use shuffling, sorry, repartition. If you are not using data further, if you want to saving data in output storage, then use coalesce function. So this is mandatory question in any interview. So these are three important points. If you explain these three important points, so you will get one perfect answer. So that's it for Spark core, and we'll start Spark SQL. So we'll start Spark SQL tomorrow. Freshly we'll start instead of mixing Spark concept with the Spark SQL. We'll start Spark SQL concept freshly in tomorrow class. Okay. So I'm stopping now. Tomorrow we'll discuss Spark SQL.